Hi everybody, this is the practice test for the concept byte and section 6.1 to 6.3 for Friday, February 19th. Now, you probably want to print out a copy of the practice test if you didn't pick one up from school already. I did have this in the gigantic stack of stuff. So in the black folder entitled Digital Copies of Worksheets and Handouts, remember this is February 19th that we're doing this. So if you come down here a ways, you'll see that we have the Algebra 2 practice test, concept byte, and section 6.1 to 6.3. And this is for both Friday, the 19th, and then Monday, the 22nd. So distance learners, if you didn't come in and get a packet, this would be a good thing to print out so that you can follow along, or you could just have it on your screen here while you're watching the video, do a split screen type of thing, whatever you need to do. Follow along so that you see the problems that are here, because the whole reason for the practice test is it's like the test but with different numbers. So you get a chance to see which particular topics are going to be focused on for the test. And then after the test, let's go back into that black folder. We have a review assignment, but the review assignment this time is not going to come from the book. It is a worksheet. So it's down here, Algebra 2 worksheet to review for the concept byte and section 6.1 to 6.3. Again, those that were in class or picked up a packet, you already have this. It's already been copied off. Those that don't, print it off if you like, but you don't have to. You can always just put your work on notebook paper. And the reason I'm focusing on this right now is because what you're going to want to do is do about half of this over the weekend and then save another half of this to work on right before the test on Monday night. If you do it all before the weekend, then chances are pretty good you're going to forget some of it. So this is one review assignment. This worksheet right here, one review assignment over 2 days of review. So let's get started on that practice test. Things to have handy for this practice test. You want a calculator, like I have this one here, and you want to have your power chart. And that I'll have to do some finagling to get all of this stuff to show up at one time here. But you want all of those things available for the use of the practice test for concept byte and 6.1 to 6.3. So the first problem we see here, and you always want to read the directions. I know that sounds obvious, but sometimes people miss those things. And in the bold, we see simplify each expression. Use only positive exponents in your final answer. That's a huge hint. You know, we're supposed to know that you don't leave those negative exponents in, because then it's not simplified. So we have the quantity 3x to the third y to the negative fourth, and all of that is going to be raised to the third power times x to the sixth y to the 12th. So what we need to do is follow the order of operations. And we have a set of parentheses here, and it actually has something inside of it that's not simplified yet. And that's going to be that negative fourth power. Now there's two ways to do this one, and the easiest way is to just kind of ignore that negative for a little bit and say, I'm going to raise everything in the parentheses to the third power. And when we raise a power to a power, so x to the third raised to the third, we have to multiply the exponents. Y to the negative fourth raised to the third power will be the negative 12th. And I still have to multiply that by x to the 6th, y to the 12th. And here's why I said I wouldn't worry too much about that y to the negative 4th. It doesn't matter if you move it down to the bottom right away, or you can now see, hey, when I multiply, I'm supposed to add exponents, and negative 12 plus 12, that's going to cancel itself out. So we'll have 3 to the third, x to the 9th times x to the 6th would mean, again, adding those two exponents together. 9 plus 6 is 15. Negative 12 plus 12 for the y's is y to the 0. And yes, I'm going to write that down, even though we all know that's 1. So we'd have 3 to the third, 3 times 3 times 3, which is 27, x to the 15th. If you needed to, you could use that power chart for 3 to the third, but most of you can probably do 3 times 3 and get 9, and take that times 3 and get 27. So we have 27x to the 15th. And then we start thinking, oh, Well, are we supposed to put absolute value bars on any of this stuff? And the absolute value bars, we did not start working with those until we started to talk about the radicals. So test-taking strategy, you look down at the bottom of the page and you see, oh yeah, it's that stuff, because in the instructions it says simplify each radical expression and use absolute value symbols when needed. So they're actually even reminding us. So no absolute value here. Now, let's move on to number 2. In number 2, it's pretty obvious that we're supposed to do division. We see that this is a fraction. So start thinking, well, 21 over 14, I know how to reduce that. 7 will go into both of those, and 7 goes into 21 3 times, and into 14 twice. And then I have to figure out what to do with the rest of that. So for a second, I'm just going to leave that 3 halves. And I remember that, well, when we multiplied similar bases, we added the exponents. So if we're going to divide similar bases, we have to subtract the exponents. So I would have to take a to the negative 4th, and if this is a little a to the 1st down there if it doesn't have anything for an exponent, and I'd have to subtract. So negative 4 minus 1 would make that a to the negative 5. And then with my b's, I have b squared divided by b to the 4th. 2 minus 4 would be b to the negative 2. And then my c is to the 3rd power divided by to the negative 2 power. And again, I have to subtract, but 3 minus a negative 2 is 3 plus 2, which is 5. Now what that does is it helps me to figure out where are the variables going to have to go. Anything with the negative exponents has to go down to the bottom of the fraction, but anything with the positive stays on the top. So c to the 5th is going to stay on the top. That's a positive exponent. But a to the 5th and b squared, those have to go down to the bottom in order to become positive. Because like it said, use only positive exponents in your final answer. And there is nothing else we can do with that one, so I suppose I should be writing these in, these little blanks. Although I write so big that sometimes it's impossible. So this one would be 3c to the 5th over 2a to the 5th b squared. My smartboard is being difficult. All right, so 3c to the 5th over 2a to the 5th b squared. Number 3. Number 3, we see multiple negatives going on here. And again, if people are going to make mistakes, it usually involves negatives. So, take a look at it and say to yourself, wait a minute, I can do some simplifying inside those parentheses because the order of operations says do what's in there first. And what I know can happen is that m to the negative 3rd can go down to the denominator and become positive. Well, now I still have a negative power. Well, those are easy enough to get rid of. Take the reciprocal. Flip the whole thing. And now it becomes a positive 2 because the negative power was just for the reciprocal. And now I look inside the parentheses and I see that it's pure multiplication and division. There's no plus or minus anywhere in there. So I can distribute that power of 2 to every single one of these, including the 4 and the 3, which currently have a 1 for their exponent. So 4 to the 1 times 2 will be 4 to the 2nd power. M to the 3rd squared, raise a power to a power, multiply, that'll be a 6. N to the 4th over 3 squared. Everything in those parentheses gets that 2. And then we'd go ahead and square 4 and square 3. 16 m to the 6th n to the 4th over 9. Or you could always write it as 16/9 m to the 6th n to the 4th. Either way, it's correct. There it is. So again, negatives, sometimes you want to deal with them right away. There are multiple ways to deal with it. The best thing to do is to say, if I follow the order of operations, what would I do first? That way you won't be confused about what it is you should take care of. So there are the first three that all had the direction: simplify each expression, use only positive exponents in your final answer. You take a second look at your answers and you say, got it, totally fine. And then hopefully you say, ooh, I like these. These aren't going to be that difficult. Find all the square roots of each number. So the square root of 196. Well, if you need to, you can go to the power chart. Second power. And then we see 196. And that would be 14. And with this one, because it says find all real square roots, and we had to write that square root symbol, we definitely, when we write a square root symbol, we put a plus or minus on our answers. So positive and negative 14. It's only if they already have the square root symbol on there that we don't need to do that. But any even roots, we have to physically write the square root, fourth root, sixth root, 4. We need to do the plus or minus. And then B, we need the square root of negative 121. So this takes us back to that slot filling. You know, both of these questions are about the filling of slots here. And we have 2 of them. And hopefully with B you realize, well, we're not going to be able to do that. That would be imaginary. You can't take 2 positive numbers and multiply them together and get something negative. You can't take 2 negative numbers and multiply them together and get something negative. So this one has no real solutions. As basic as that for those 2 problems. Again, you double check, you make sure that you did everything you were supposed to do, find all the square roots of each number. We did it. Back to number 5 here, we see an A and a B, and it says find all the real cube roots of each one of these. So as I'm writing it down, I'm thinking cube roots only get one answer because this is 3 slots. And since that's a negative 729, it's going to have to be negative, whatever it is. So now, we'll go to the power chart. Third power, 729, there it is, all the way over to 9. So the answer to that one would be negative 9. All right, number 5. 512 over 216. Wait a second. Those are both even numbers. That can be reduced. Well, if you don't want to do the reduction by your head, your brain, you could always grab your graphing calculator, because remember, your graphing calculator reduces, and plug it in as parentheses 512 divided by 216. Enter math number 1, and it reduces to 64 over 27. And now we need to take the cubed roots. So we'll want the cubed root of 64 over the cubed root of 27. And hopefully you knew that one right off the bat, cube root of 27. We've seen that one a lot. But maybe, just maybe, you didn't recognize the cubed root of 64. So cubed root 64, that's going to be a 4. And again, with cube roots, it's positive or negative. It's never both. So it makes sense that we'd have 4 thirds times 4 thirds times 4 thirds, because with fractions, We always multiply numerator times numerator times numerator divided by denominator times denominator times denominator when we're talking about cubes. So there they are. Again, check the directions. Find all real cube roots of each number. Did it! Yay! I got it! All right, now, for those that are getting a little more complicated, not a lot at the beginning here, but by number 12, yeah, we're starting to see some more complicated stuff. So, number 6, simplify each radical expression, and you probably want to circle this or underline it or something so that if you do forget, when you come back to check the directions later, you'll go, oh man, I forgot to put the absolute value bars on there, and you can go back and take care of that. So for number 6, this one is square root, and then we notice, oh, we have both numbers and variables under there. So I want to separate those first. And then the square root of 144, that's 12. That works out nice. And then you have the two ways to figure out what do I get for the x's and the y's. Some of you are already using division and you're saying this is a 2 and you're going from there. But again, everybody understands it if you break it up into perfect squares. So we'd have the square root of x squared, the square root of x squared, and the square root of x squared. Because if you add 2 plus 2 plus 2, you get the 6. And when you multiply similar bases, that's what you're supposed to do. And then for the y's, square root of y squared, square root of y squared, square root of y squared, square root of y squared. So that those are perfect squares. And 2 plus 2 plus 2 plus 2 is 8. So we have 12, and we have an x, an x, and an x. X to the third. A y, a y, a y, and a y. Y to the fourth. And last but not least, we think about that big circled instruction up there. Use absolute value symbols when needed. Well, this had an even root. It was a square root. There's our even root. So any odd power answers need absolute value bars. And again, this is all about the variables. This variable has a 3 for its power, and that is odd. So that's going to need absolute value bars. So we have 12, absolute value of x to the third, y to the fourth. Number 7, which I'll have to try to make some room for here. That's that blue marker again. All right, got to wait for the light to come on and be patient. There we go. So for number 7, we have cubed root of negative 216. So let's go ahead and separate that from cubed root of a to the 12th. I'm going to come down here where I have a little space. Now cubed root of negative 216. Well, that just might be something with a negative on it that shows up on our chart. So let's go to the power chart. Cubed root 216 all the way over here to 6. So that's going to be a negative 6. And then we need to break up the a to the 12th so that it's in perfect cubes. So cubed root of a to the third, 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 because 3 plus 3 plus 3 plus 3 is 12. And that will be a times a times a times a, which would give us negative 6a to the fourth. And then you ask yourself, should I be putting some absolute value bars on that? No, it was a cube root. Cube roots are not even. Has to be even root, odd power answers. So this is going to be negative 6a to the fourth. Number 8. Fourth root of 3,125. Oh my goodness. Well, let's break it up. and then 4th root of x to the 7th, 4th root of y to the 13th. So let's see if the 4th root of 3,125 is something perfect. 4th power, oops, it's not there. If it were, it would be right in here, but it's not. Oh, all right, so 3,125. Let's look for anything up to 7 to the 4th that might divide into it nicely. And I notice it has a 5 at the end. So numbers that end in 5 would divide nicely into things that end with 5. I would try 625 and see if that works. So you'd grab a calculator and see. Does that go in evenly? Oh, look at that. It does. Fantastic. We'll go back and rewrite this as the 4th root of 625 and the 4th root of 5, because that was the math we just saw on the calculator. Then we'll have the 4th root of x to the 4th, but it won't go in there twice because it'll go in once with a remainder of 3. So there's our little ugly remainder of the 4th root of x to the 3rd. For the y's, we'll have the 4th root of y to the 4th, the 4th root of y to the 4th. If we do 4th root of y to the 4th one more time, now we have 4 plus 4 plus 4, which is 12. We're going to have one ugly remainder of y to the 1st there, 4th root of y to the 1st. So now let's see what we have that would be nice. The 4th root of 625 is 5. That's going to be nice. This 4th root of x to the 4th, that's going to be an x. That'll be nice. Not the other one. That one's got a remainder. This y, and this y will all work out, but that last one's an ugly remainder. So 5xy, and now let's go find all the ugly stuff for underneath the radical symbol. So we used this, we used this, we used these, and what we have left is a 5, an x to the 3rd, and y to the 1st. And what I want you to notice there is I used a strike to go through those. I didn't scribble because then whoever it is that's grading my paper can't see what my work was. But if you put a strike through it, then I can make sense of what it was you were doing as you go through there. So we have 5x y to the 3rd and our 4th root of 5x to the 3rd y. Well, last but not least, even root, odd power answers in the pretty part. Well, that's both of these. X to the 1st and y to the 1st. And I was just thinking, I don't even want to try and fit that in the little spot they have for 8 up there. I think I'll just put a box around it right here. So again, don't forget that you put a big circle or underline, use absolute value symbols when needed. You know, even if you forget, come back to it later. Do it later. Alrighty, we are at number 9, the cubed root of 125, a to the 12th b. And my guess is that right now, most of you already know the cubed root of 125. We've used it so much, that's 5. And then you go ahead and do either your separation into your groupings of a to the 3rds, so cubed root of a to the 3rd, a to the 3rd, a to the 3rd, a to the 3rd. 3 plus 3 plus 3 plus 3 is 12. So you'll notice this is a, and a. That'll be a to the 4th. And then you've got one little b sitting there. So cubed root of b. Now, the reason I said you can do this or is because, again, some of you have already figured out that you just divide. 3 divided into 12 gives you a to the 4th. Now, that cubed root of b to the 1st, there isn't anything we're going to be able to do with that. So we'll have 5 a to the 4th cubed roots of b. Then stop and say, was it an even root? Oh, no, it was cubed root. So I don't need to worry about absolute value bars. Number 10 has the square root of 98, and then we've got s to the 6th, t to the 8th, s squared, and s squared would give me s to the 6, adding those exponents. Then we've got t squared, t squared, t squared, and t squared. 2 plus 2 plus 2 plus 2 is 8. And we start working on that 98 because we realize the square root of 98 is not something nice. So let's go to the power chart. Square root means second power. 98 would have been there. So we're looking to see, does 81 go into it nicely? Does 64 go into it nicely? And you'd just grab your calculator and you'd keep working on that. And 81 doesn't go into it. 64 doesn't go into it, but 49 does. 49 goes in perfectly twice. And then you take stock of what do I have for s's and what do I have for t's. So we have s, 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 which is s to the third, t, 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 t to the fourth, and we know that the square root of 49 is 7, so that's pretty. S to the third is pretty, t to the fourth is pretty, square root of 2, not so much so. And this was square root. That is an even root, so any of our variables in the pretty part that have odd power answers are going to need absolute value bars. That is the s to the third. And I just stopped it for a second so I could write the answers for 9 and 10 in the little slots over there. And now I have to find some room for number 11. Let's see, I think I'll put that one down here. So cubed root of 432 y to the 7th. All right, 432, huh? So cubed root of 432, cubed root of y to the third, y to the third, y to the first, because 3 plus 1 is 7. And now the cubed root of 432, that doesn't seem very familiar. So let's go to the power chart. Cubed root, well, that's because it's not on there. So we would grab a calculator and we'd take 432 and we would divide it by 343, but probably not because we know that's not going to work. Then we'd try 216. Well, 432 divided by 216 works perfectly. Gives you a 2. So this is going to break into the cubed root of 216, the cubed root of 2, and then we'll have a y and a y, so y squared, and another cubed root of y to the first. And then the cubed root of 216, as you go back to your power chart, that's a 6. Remember, we have a y squared that was nice, but everything else has to stay under the ugly radical symbol. So 6y squared, cube roots of 2y. Then you ask yourself, do I need absolute value bars on number 11? And the answer to that is no, it was cubed root. Cubed root, that's odd. That does not require absolute value bars. Alrighty, getting down here to the bottom. So we have number 12 to look at. We'd separate this one, fifth root of negative 729. Then we've got fifth root, but it's x to the 11th. So x to the 5th, x to the 5th, but that's only 10. So I need one more. 5 plus 5 plus 1 is 11. And then the fifth root of y to the 5th, but that leaves me with an ugly remainder of 3 of them. 5 plus 3 is 8. Fifth root of negative 729, huh? Let's go take a look at that power chart. Fifth root you can ignore the negative. We already know we can take care of that just by putting a negative on this since it's going to be fifth root. But we'd have to try them. I mean, we need to see, does 243 divide into 729 evenly? It does 3 times. So the question comes up, well, do I take the negative with or do I leave that with the little 3? Take it with. We know the fifth root of negative 243. We're just going to put a negative in front of the fifth root of 243, which is 3. And that went in 3 times. We know we have an x and another x. That's x squared. But then this one is going to have to stay under the ugly symbol. We have a nice y. So there's a nice y to the first. But again, we have an ugly fifth root of y to the third. So let's see what we can do here. The fifth root of negative 243 would be negative 3. We have a nice x squared and a nice y to the first. But then we need the ugly stuff. That's going to be a 3, an x to the first, and a y to the third. And finally, we have to ask ourselves whether or not we're going to need some absolute value bars on this thing. And we look at the index and see it was a fifth root and say, nope, that is odd. Even roots with odd power answers require absolute value bars. I'm not going to try and fit that one in a little slot over there. So there it is. Now, do the same thing I did with the initial problems 1 through 5. You've finished this section, go back up and read the instructions one more time. Simplify each radical expression. Oh, and here's where some of you will catch yourselves. I forgot to do the absolute value thing. Well, you can go back and do that now. Go back and look for any of those even roots with odd power answers in the pretty part, and you'll get it. Now that's a little bit more than half of this practice test, but I'm perfectly fine with that because I felt the front page was a good place for a stopping point. So I've got half of this done, and as I mentioned earlier, what you want to do is get a pretty good start on this review. And it was given to you in the stack. It's a white worksheet packet that you'll find in there in the stack of handouts. If you're distance learning and you don't have the handouts, you can just scroll this up and down, take a look at how many problems there are, and then ask yourself, what am I going to have time for on Monday? And try to do at least half of this over the weekend, so that you're not leaving yourself a ton of problems to deal with. And that is Friday's lesson. Covered the practice test and the homework that you need to do. Have a great weekend.